Hello everyone, welcome to Chemazon-Complete Chemistry. So these are the last 51 to 60 questions. That is the last 10 questions. Each question is of 2 marks. There is no negative marking. There is no negative marking. Okay, first question, question number 51. The degree of unsaturation for the following product B is. Okay, now you can see this is an organic reactant. This is the alpha carbon. Okay, this is a functional group. Carbon next to functional group is alpha carbon, alpha bromo. So this is a alpha haloketone. Okay, and in this type of molecules, which reaction, name reaction takes place? Favorsky rearrangement. Okay, it is a name reaction, that is a Favorsky rearrangement. What we have to do? We have to first draw the product. Product is B. That product, we have to find out the degree of unsaturation. So let us first draw the reactant that is given. C double bond O, Br, carbon, pH, CHO, and here we have cyanide. First step is, this is the acidic proton that will be abstracted by OET. OET minus, this will abstract this proton. Negative charge will come here. Okay, negative charge will come here on this carbon. This will attack here and Br will go away the leaving group. What we will get is, we will get a 3-membered ring like this and the remaining 5-membered ring like this. C double bond O and carbon pH dash we have C double bond OH. On the wedge we have cyanide. Okay, cyanide. So now what will happen? It is an OET minus. Okay, so OET will act as a nucleophile now. This will break. Okay, this will open up. O minus. O minus will come back. Now the question is, which bond will break? Okay, either this bond or this bond. Let's say this is A, this is B. Okay, A, if I break this, here you can see there are electron withdrawing groups, cyanide and aldehyde. So this is more stable as compared to here. If I draw a negative charge, here there is CH2 that will donate electron, that will make it more unstable. Carbocation stability, for the stability of carbocation, we want an electron withdrawing group, not an electron donating group. Okay, so what will happen? This is the 5-membered ring. Okay, and B is not stable, so B will not take place, A will take place. Okay, what we will get is, this 5-membered ring is as it is. This group is also as it is, pH, C double bond OH, and on the wedge there, on the wedge there is cyanide. Here we will have C double bond O, OET is CH2, CH3. This is going to be the final product. Now what we have to do, okay, here negative charge was formed, that will pick up a proton and it will become like this. Okay, here H will come. Now we have to find out the degree of unsaturation. Now before finding out the degree of unsaturation, I want you to tell me the degree of unsaturation in this. It is for saturated bonds, that is alkane, degree of unsaturation is 0. C double bond C, degree of unsaturation is, there is 1 pi bond, so degree of unsaturation is 1. In C triple bond C, there are 2 pi bonds, so degree of unsaturation is 2. Similarly, for one ring, the degree of unsaturation is 1. Now we can find the answer. There is this 5-membered ring. Okay, we start from here. This is 1. Okay, double bond, so 1. This is ring, so 2. Cyanide, there are 2 pi bonds, so this will be 2. Here there is 1. And pH, we cannot forget pH. pH is what? pH is benzene. Okay, if I consider benzene, benzene is what? Benzene is 1 6-membered ring and I add 3 pi bonds. Okay, then I will get benzene. Okay, so 1 plus 3. 1 plus 3 is how much? So for every benzene ring, degree of unsaturation is 4. Now it is very simple. We have to just add all the values. Okay, 1 plus 2. Okay, for this, okay, this is the second number. Degree of unsaturation is 1. 1 plus 1 plus cyanide 2 plus 1 aldehyde group. Then in pH there are 4. So 1 plus 1 2, 2 plus 2 4, 4 plus 1 5, 5 plus 4 9. So the correct answer is going to be 9. Okay, the correct answer is degree of unsaturation is 9. Next one, 52. A 002 plane in an elemental FCC. FCC means Z is equal to 4. That is the number of atoms in one unit cell. 002 is given, that is H is equal to 0, K is equal to 0, L is equal to 2. This is the plane. Okay, 002 plane that is given. Next, what is given? Wavelength is given 0.154 nanometer. You can see density is in kilogram per meter cube. So I can convert this into meter. 1 nanometer is 10 raised to minus 9 meter. Then we have density. Density is what? 40,000 kg per meter cube. Meter cube is fine, but we want it in gram. Why? Because the final answer we want in gram. So we'll convert this into gram. 40,000 I can write it as 4 into 10 raised to 4 into 1 kilogram is kilo is 10 raised to 3 gram divided by meter cube. This, if you see, it is 4 into 10 raised to 7 gram per meter cube. Okay, what we want? We want atomic weight. Now can write down the formula. What is the formula for density? It is Z into M divided by Na into A cube. Z is the number of atoms in a unit cell. We have already written, that is 4 for an FCC. M is what? M is the molecular weight or atomic weight that we have to find out. Okay. Next is Na is Avogadro number 6.022 into 10 raised to 23 mole inverse. A cube is the volume. A is the edge length. Now if you see Z value is given, this M we have to find out. Na we know, we don't know A. Okay, but what else they have given is, we can use Bragg's equation. N lambda is 2d sine theta. Okay, we can first find out the value of D. Okay, here this is density. Okay, you don't have to get confused. I will change the symbol. Let's say rho. Rho is the density. Okay, D is the interplanar distance. Okay, so first we can find out D. Why we are finding out D? Formula of D is A divided by root of h square plus k square plus L square. Now you might say, for A, why we cannot use this formula? A is equal to 4r by root 2. This is for an FCC crystal. Radius is not given, so that is why we cannot use this formula. Okay, so for finding out the value of A, we want D. From where we will get D? From this Bragg's equation. Okay, D will be n lambda divided by 2 sine theta. Order is how much? It is given first order diffraction. So order is 1. Wavelength is 0.154 into 10 raised to minus 9 meter divided by 2 into sine 90. Theta value is given to us, that is 90 degrees. Sine 90 is how much? 1. Okay, so let us keep this like that only. 0.154 into 10 raised to minus 9 divided by 2 meter. This is the value of D. Okay, now we can substitute this in this value. 0.154 into 10 raised to minus 9 meter divided by root of 0 square plus 0 square plus 2 square. 0 plus 0 is 0. 2 square is 4. Square root of 4 is how much? 2. So 0.154 into 10 raised to minus 9 divided by 2 is same as what? same as this is what value? This is A divided by this. So this is going to be, okay, this is A. Okay, this is not, okay, let me do again. Okay, we are substituting here. D is equal to A divided by root of 0 square plus 0 square plus 2 square. So D is what? D is going to be A by root of 4 is 2. So D is A by 2. Okay, so what I can do? I can substitute here A by 2. 2 and 2 get cancelled. Okay, so now we have the value of A. Okay, I will erase this. No, this we need. Okay, I can erase from here. Okay, we want the value of M. So we will rearrange density into Na into A cube divided by Z. Density is 4 into 10 raised to 7 gram per meter cube into Avogadro number is 6.022 into 10 raised to 23 mole inverse into A cube is 0.159 into 10 raised to minus 9 the whole cube meter cube divided by Z is 4, that is unitless. You can see meter and meter raised to minus 3, meter raised to plus 3 get cancelled. We will get the answer in gram per mole. Okay, this if you solve, you will get the answer as 21.99. This we can round off to 22 gram per mole. What is the correct answer? Correct answer is nearest integer. So you will write 222. Only this 22. Next one, the EMF of the given cell is this much. So E cell is given to us, that is how much? 0.5356. Temperature is given 298 Kelvin. Temperature coefficient is given, that is dE by dt at constant pressure. This is 1.45 into 10 raised to minus 4 volt per Kelvin. Now this volt per Kelvin I can, okay, volt per Kelvin is fine. Next is value of F is not given, that is 96500 coulomb per mole. Okay, what I can do? Coulomb I can change. We know that the potential difference is work done per unit charge. So Q is W upon V, that is joule upon volt. Okay, this I can convert into joule per volt. Why I am doing this? I will tell you. Okay, this is the value of F. Again, you will say that F value is not given, that also you must know. Okay, sometimes in the question, this is the F value that is given. Okay, whatever value is given, use that same value. Okay, if it is not given, then you use this 96500. Okay, now what we have to do, cell is given, we have to find out delta H. How do you find out delta H? Okay, we will use Gibbs equation. Delta G is delta H minus T delta S. We want what? We want delta H. Delta H will be delta G plus T delta S. We don't know delta H. For that we need delta G and delta S. Both are unknown. So let us calculate delta H and delta S first. So delta G will be minus NFE. Minus how many moles are involved. Okay. For that we have to write down the cell reaction. Pb is getting converted to Pb2 plus 2 electrons. Similarly, this is Hg2 2 plus, it will gain 2 electrons and it will become 2Hg. Okay, so N value is 2. So 2 mole, the second right below. Okay, the second right here minus 2 mole into 96500 joule per volt per mole. This is 2 mole. Okay. Into E is how much? E is 0.5356. Now I will tell you why I had converted this coulomb into volt per Kelvin. Why? Because this volt inverse and volt can get cancelled. Mole inverse and mole get cancelled. We will get the answer in joule. Okay, let us keep it in joule. Delta G value will come out to be minus. This minus sign is very important. Okay. Whenever you get negative sign, you have to be very careful. 103371. This is delta G. Now we can calculate the value of delta S. Okay, delta S will be, that formula you must know, it is plus NF into dE by dt at constant P, that is the temperature coefficient. N is again 2 mole into F. F is what? F is again, we will put this value 96500 joule per volt. Okay, joule per volt per mole into dE by dt. What will be the unit? It is given volt per Kelvin. Okay, volt per Kelvin. 1.45 into 10 raised to minus 4 volt per Kelvin. So if you solve this, mole and mole inverse get cancelled, volt and volt inverse get cancelled. We got the unit in joule per Kelvin. This, if you solve, it comes out to be plus 27.99 joule. Now we can substitute and we get the value of, what? We can get the value of delta H. Delta H is delta G is minus 103371 plus temperature is 298 Kelvin. Okay, this was joule per mole. Okay, into, sorry, this was joule, not per mole, joule into 27.99 joule per Kelvin. Okay, joule per Kelvin. So Kelvin and Kelvin inverse get cancelled. Both are in joule. You add them. Final answer comes out to be minus 95031 joule. You want it in kilojoule. Okay, you don't have to put this value in hurry. Read the question carefully. Kilojoule. So divided by 1000, final answer will be minus 95 point, how many decimal? 2 decimal, 95.03 kilojoule. So the correct answer is what? 95.03, and negative sign, very, very important. Negative sign, if you forget, your answer is gone. Next question, the quantum yield of the reaction at lambda is equal to 330 nanometer is 0.4. Okay, for this, what we must know? We must know first the formula of quantum yield. What is the formula of quantum yield? Quantum yield is moles of reactant used or reacted divided by moles of photons. Okay, so what we have to find out? We have to find out the moles of, or rate of formation of CO. CO is the product in mole per second. That is, we have to calculate the moles of product. If you see the balanced reaction, 1 mole of reactant is reacting to form 1 mole of product. So moles of reactant used will be same as the moles of product formed. So moles of CO formed, okay, it is per second, so we can also call it as rate, divided by moles of photons. Okay, we don't have any of this. We don't have this. We don't have this. So we have to find out both of them. First, we will find out the moles of photons. E is equal to NHC by lambda. This is the formula we are going to use. We always write HC by lambda. This is for what? This is for one photon. But we don't know the number of photons. First, we will find out number of photons. N will be right here above. N is how much? It is E into lambda divided by Hc. Energy is given, it is how much? Okay, energy is given. Energy is 7.2 into 10 raised to minus 3 joule per second into wavelength. It is in nanometer, 330 nanometer. I can convert it into meter. It will become 330 into 10 raised to minus 9 meter. 1 nanometer is 10 raised to minus 9 meter. Planck's constant 6.626 6 into 10 raised to minus 34 joule second into speed of light is 3 into 10 raised to 8 meter per second. Now we know number of photons, which means it should be unitless. Let us see whether all the units are getting cancelled or not. Joule and joule get cancelled. Second inverse cancel. Okay, meter. Now this is per second. That is the reason. Okay, number of photons released per second. Okay, that's how we will get in the answer also. We will get per second. Okay, this entire thing, if you solve, this answer comes out to be 119.53 into 10 raised to 14. Okay, this is the total number of photons. We know 1 mole is how much? 6.022 into 10 raised to 23. So this many photons will be how much? Okay, 119.53 into 10 raised to 14 is, let's say, x mole. So moles of photons will be 119.53 into 10 raised to 14 divided by 6.022 into 10 raised to 23. This answer comes out to be, okay, this is per second, okay, per second. So this answer comes out to be how much? Comes out to be 1.98 into 10 raised to minus 8 mole per second. Now substitute. We can substitute here. We want moles of product. Okay, so moles of product moles will be quantum yield, that is 0.4 into the moles of photons. Moles of photon is 1.98 into 10 raised to minus 8 mole per second. Okay, that is how we get the answer in mole per second. This, if you multiply, the final answer is going to be how much? Okay, 0.4 into 1.98 into 10 raised to minus 8. This comes out to be 8 into 10 raised to minus 9. Okay, we have to write the nearest integer 8. Okay, the actual answer comes out to be 7.94 into 10 raised to minus 9. This 7.94 we can round off to 8. Only one integer means 1. Next one, 55. How do you solve this? The energy of activation is what? It is additive. Always remember, this is, we can add them, and rate constant is multiplicative in nature. How do you find out rate constant? Overall rate constant is given K1, K2 divided by K3, the whole raised to 2 by 3. So how do you find out the overall activation energy of the reaction? First, this 2 by 3 you take common. Whatever is there in multiplication you add. Whatever is there in divide you minus. You can remember the log rules, okay, similar to that. If it is multiply, then you add, subtract, then you minus. K1 into K2. So corresponding to K1, EA1 is how much? Okay, this will be EA1 plus EA2 minus EA3. Substitute the values. 2 by 3, EA1 is how much? 180 plus 80 minus EA3 is 50. This will be how much? 80 minus 50 is 30. 30 plus 80 is 210. 3 ones are 3 70s are. 7 into 2 is 140. Okay, 140 unit is kilojoule. Kilojoule per mole. So the final answer is what? Nearest integer 140. Next question, 56, turnover frequency. Okay, now if you don't know turnover frequency, you cannot solve this question. What is turnover frequency? Turnover frequency is K2. Okay, K2, some textbooks they write K2. Okay, it is K2. You remember that. Okay, turnover frequency is K2. Everything is given to us. We have to just use the enzyme kinetics, that is Michaelis-Menten equation. Michaelis-Menten equation. You must remember this equation. It is rate is equal to K2 into concentration of enzyme into S divided by Km plus S. Okay, what we have to find out? We have to find out K2. K2 we have to find out. E naught is given, S is given, Km is given. Okay, E naught is given how much? Okay, E naught. Okay, E naught or E both are same. Enzyme concentration. Rate is also given. Substitute everything and find out the answer. So K2 will be how much? K2 will be rate into Km plus S, concentration of substrate divided by concentration of enzyme into substrate concentration. Rate is how much? 0. Rate is how much? 0.205 unit mole per dm³ per second. Okay, into Km plus S. Km is what? Km is Michaelis-Menten constant 0.032 plus substrate concentration is 0.875. Unit is mole per dm³ divided by enzyme concentration is 0.123 mole per dm³ into substrate concentration is 0.875 mole per dm³. Cancel the common units. Mole per dm³ cancel, mole per dm³ cancel, mole per dm³. What we are left with is S inverse. That is the unit for turnover frequency. Frequency, what is the unit? Hertz. Hertz is what? Hertz is second inverse. Solve this entire thing and the final answer comes out to be 1.73 up to 2 decimal places. Okay, 1.73 second inverse. 1.73. Next is 57. What is given to us? Let us write down the given data first. Molar heat of vaporization in the temperature range 363 and 373. Higher temperature T2 is 373 Kelvin. T1 is 363 Kelvin. Vapor pressure of water at higher temperature, that is P2 is given to us, that is 1.013 into 10 raised to 5 Newton per meter square. We have to find out the value of P1. Enthalpy of vaporization is given 40.65 kilojoule. Convert this into joule. 40.65 into 10 raised to 3, that would be 40650 joule per mole. Okay, again the enthalpy of vaporization, this is very very important. They have asked so many times Clausius-Clapeyron equation. Okay, this is from Clausius-Clapeyron equation. Okay, just write down the equation. Ln of P2 by P1. P2 is partial pressure at higher temperature. P1 is at lower temperature. Lower temperature 363 degree we have to find out. P2 is given is equal to delta H by R. Remember we are writing ln here, so it will be R. If here by mistake if you are writing log, then you have to write here 2.303. Okay, but we are taking what? We are taking ln. And one more thing, log base is 10. Okay, that also you must know. While putting in the calculator, you should write 10 raised to if it is log and e raised to if it is ln. Okay, so write down 1 by T1 minus 1 by T2. So ln P2 is how much? P2 is 1.013 into 10 raised to 5 Newton per meter square divided by P1 is equal to delta H is 40650 divided by R is 8.314 joule per Kelvin per mole into 1 by T1 is 363 minus 1 by T2 is 373. Unit will be 1 by Kelvin. Check the units. Very, very important. Before finding out the final answer, check the units. Kelvin, Kelvin inverse get cancelled. This is joule per mole. Okay, and this is also joule per mole. So joule per mole get cancelled. E raised to something should be unitless. Okay, so the units are correct. Final, this value 1.013 into 10 raised to 5 Newton per meter square divided by P1. This value comes out to be 0.361. How will you find out the value of P1? P1 is going to be, sorry, this is e raised to 0.361. This is 1.435. Okay, so what will be the value of P1? P1 is going to be, P1 will be 1.013 into 10 raised to 5 Newton per meter square divided by 1.435. Final answer comes out to be 0.697 into 10 raised to 5 up to 3 decimal places, 0.697. So right here 0.697 up to 3 decimal places. Next one, 58. How do you find out the microstates? Okay, the formula for microstates is, okay, there are two formulas. One is when electronic configuration is given. Then what is the formula? You write n factorial upon r factorial into n minus r factorial. N is total maximum electrons that can be accommodated. R is the electrons that are filled. Suppose I write D3. So D means maximum is 10. So value of N will be 10. What will be the value of R? R will be electron filled is 3. In this way you can solve. But here the configuration, the ground state term is given. 3I and 3G. What is the formula for this? Formula for this is number of microstates 2s plus 1, that is the spin multiplicity into 2l plus 1. Okay, for that we must know this thing that how do you find out the values of L? If what is the value of L and the term 0, 1, 2, 3, 4, 5, 6. Okay, this is S, P, D, F, G, H, I. Okay, so here there is I. This is the spin multiplicity. Okay, how do you generally represent 2s plus 1? Okay, 2s plus 1 into L, and here there is this J. Okay, so this is the spin multiplicity. So 2s plus 1 is 3 into L. I value, okay, for I, L is how much? 6. So 2 into 6 plus 1. 2 6 are 12 plus 1, 30. 3 are 39. Similarly, for G, 2s plus 1 is 3. Sorry, this is 5G. 5 into 2 into, for G it is 4. 2 into 4 plus 1. This is going to be how much? This is going to be 2 4s are 8 plus 1, 9 5s are 45. Sum means add both of them, 9 plus 5 14, 4 1, 3 4 5 6, 7 and 8. Correct answer is 84. 59 number of WW bond, metal metal bonds. WW means metal metal bonds we have to find out. Okay, so W is how much? It belongs to D4. So 4 plus 2, 6. Plus hapticity is 5 plus Cl. Always remember whenever Cl is in bridge, it donates how many electrons? 3 electrons. Very, very important. When you see mu Cl, there will be 3 electrons. If it is terminal like this, then it donates 1 electron. So here it is 3 plus CO. CO is 2 electron donor. This is how much? 6 plus 5, 11 plus 3, 6 plus 5. Okay, this is 4. Okay, 2 into 2 carbonyl. So 2 into 2, 4. 6 plus 5, 11. 11 plus 3, 14. 14 plus 4, 18 into 2. Into 2 is 360. Sorry, 36. 18 into 2 is 36. How do you calculate metal-metal bond? Total valence electron, that is 36 minus 18 into N, divide by 2. 36 minus 18 into central metal atom is 2, divided by 2. 36 minus 36 divided by 2 is 0. 0 divided by 2 is 0. So the answer is 0. Now the question is, you might ask that if the metal-metal bond is 0, then why are we asking this question? Okay, let us understand that. Just like how we find out the bond order for helium-2, it is what? It is 0. What is the meaning of that? Helium-2 does not exist, it exists as a monomer. Similarly, if they have written like this, C5, eta 5 C5H5 mu Cl CO twice and whole of twice. This whole of twice means it is a dimer. Since the metal-metal bond is 0, dimer will not exist. Dimer will not exist, so you remove this. This is how it will exist. It is a 18 electron complex. We know 18 electron complexes are stable. If 18 electron complexes are stable, why it will form a dimer? Okay, that is the question. It will not form dimer. If it will not form dimer, metal-metal bond will be 0. Last question, vibrational frequency of the molecule is this much. So E vibrational is given for the ground state. Okay, I can write this as 0. Sorry, this is vibrational frequency that is given. That is how much? Okay, it is represented by nu, or it is represented by omega 2 into 10 raised to 5 centimeter inverse. Okay, what is the formula? E is equal to V plus half nu. Nu bar. This is nu bar is in centimeter inverse. So to convert, okay, remember this. If you want to convert joule to centimeter inverse, you divide by HC. If you want to convert centimeter to joule, you multiply by HC. So here it is in centimeters, so we will multiply by HC. V plus half HC nu bar. Okay, it is ground state, so E becomes E0. V is what? V is vibrational quantum number for ground state. It is 0. 0 plus half is half. HC nu bar. Okay, substitute all the values. Planck's constant 6.626 into 10 raised to minus 34 joule second into 3 into 10 raised to 10 centimeter per second I am putting, because C is 3 into 10 raised to 8 meter per second. What is meter? 1 meter is 10 raised to 2 centimeter. This, if you solve, this is 3 into 10 raised to 10 centimeter inverse. That is what I have written. Into frequency is given 2 into 10 raised to 5 centimeter inverse. Okay, here if you see centimeter, centimeter inverse get cancelled. Second inverse get cancelled. We will get the answer in joule. This, if you solve, the final answer will be 1.988 into 10 raised to minus 18 joule. but you have to check that the question it is asking in electron volt. Now you must know 1 electron volt is 1.6 into 10 raised to minus 19 joule. So what will be 1 joule? Divide. 1 joule will be 1 upon 1.6 into 10 raised to minus 19 electron volt. So what we have to do? We have to divide it by 1.6 into 10 raised to minus 19. We will get the answer in electron volt. Final answer comes out to be 12.42 up to 2 decimal places. So the correct answer is 12.42. So I hope you have understood all the solutions, and I hope and pray that similar questions or the questions that we have solved come in the exam. All the very best for your exam. Thank you so much.